This is the Energy Makers Show, featuring the innovators, financiers, and policymakers focused on the global energy demand. Brought to you by NRG, moving clean energy forward. And here's your host, Paul Dickerson.
Hi, I'm Paul Dickerson, and welcome to another episode of the Energy Makers Show. Our topic today, natural gas for transportation. More specifically, the home version of natural gas compression systems that are really solving the problem of infrastructure in the non-fleet CNG vehicles. We have Russ Capper reporting in from the Center for Electromechanics at the University of Texas in Austin, where he sits down with the director of the center, Dr. Robert Hebner. All that right after this.
Where will the energy come from to move us forward? From natural sources in abundant supply, or perhaps a man-made source? At NRG, we believe innovation will solve our energy needs. That's why NRG is moving away from fossil fuels towards wind, solar, and other sustainable technologies to power the smart grid, the electric car, and our clean energy future. We're using all of our energy to develop more of it.
This is the Energy Makers Show, brought to you by NRG, moving clean energy forward. And now, back to the Energy Makers Show.
Welcome back to the Energy Makers Show, coming to you today from the Center for Electromechanics at the University of Texas in Austin. And our topic for today is compressed natural gas for transportation, and more specifically, the home filling compressor that changes the infrastructure challenge for non-fleet CNG vehicles. And my guest is the director of the Center for Electromechanics, Dr. Robert Hebner. Bob, welcome to the Energy Maker Show.
Well, thanks for asking me, Russ.
You bet. Well, let's talk first about this place, the Center for Electromechanics.
The Center for Electromechanics is a research center at the University of Texas of Austin, primarily with mechanical and electrical engineers focused on energy. We work on smart grid, we work on alternate biofuels, we've done a lot of work on the oil and gas, with the oil and gas industry, on exploration, drilling, platform power systems. We've made vehicles, both buses, Humvees, trucks, utility vehicles. So we've made vehicles that are run on alternate fuels. Our hybrids have a variety of improved performance characteristics.
Well, that sounds really cool. Now, as I mentioned in my introduction, though, we're here today to talk about your mission with CNG vehicles, specifically this home compressor unit. Tell us how that got on your radar.
Well, we've been working for a while with the people that are using the plug-in hybrids who are worried about with electricity. With the growth of natural gas, the reduced prices of natural gas, the realization that natural gas is a fuel that's available today, we said, can we do the same things that we're doing with the plug-in hybrid? Can we do that with natural gas? Can you drive it home in the evening? Can you plug it in? And then when you need to leave in the morning, your car is completely full of natural gas. Is that possible? We with a little research, we found, yes, it's possible, but it's way too expensive and too unreliable. So then we ask ourselves the question that this center asks a lot: can we make it cheaper, and can we make it so that it works all the time? And the Department of Energy had a competition asking for people who could reduce the cost and increase reliability. And fortunately, we were ready with some very good ideas that we think we have a sporting chance of really changing the way that we can use natural gas.
Well, and from what I understand, the federal government believed that you can and awarded you a pretty nice little deal through their ARPA-E program, right?
Yes, they did. We competed for and received a $4.2 million grant with our partners, because one of the things that this center does is, our objective as a university center is every 5 years to have three products into the marketplace in this energy field. And so that means we always try to work with industry, we always try to work with partners, so that as we finish our R&D, we have a process in place that our technology can get out to the users.
Well, I think it's real interesting how you sort of got interested in it through the electric vehicle route, because that's what got on our radar too. The EVgo people, subsidiary of NRG, we've had them on several shows over the last couple of years. And to me, the fact that you could home charge in your garage overnight, it took time out of the day over a period of time of having to go to a station. And the fact that you can do that with natural gas, I think is really cool.
Right.
And people are doing it today, though, right? There are compressors in people's garages today, right?
Right. There are people who will convert vehicles to natural gas, and there are compressors that do exist. They generally are viewed as too expensive and not sufficiently reliable for mass use.
Okay.
But this is not, we did not invent the technology. Right. We're trying to improve the technology.
Okay. Is it, I mean, after you take on a mission like this, is it obvious to you, or you wouldn't have competed for the money, that it can be improved significantly, the reliability and the cost? That was our expectation.
Right. We've done a lot of this. We realized the size and the number of moving parts made the existing systems very expensive. They tended to evolve from other applications to this application. We just decided to go with something purpose-built, trying to get down to one moving part that could actually be in your home and could charge your car.
Okay, from what I understand, too, that the existing natural gas compressors today have, like, I read 4 and 5 pistons in them, and so that's what you're thinking, wow, if we can just get this down to one, it could be significantly less expensive and more reliable.
That is precisely it. We're trying to get the number of moving parts down so that it's easy to make, easy to maintain. It's going to be lighter and cheaper.
Okay. So how do you do that in a research center? I mean, I assume you have, smart people working with you and for you. You don't go do it yourself, do you?
No, I don't go do it myself. We have a team. There's a team that is working on this.
And are these graduate students, PhD students?
We have students, and we have full-time researchers. The interesting thing, when you go into commercialization, we need to have the academic faculty, we need to have the students, but we also need to have some full-time researchers, because the world doesn't stop for finals week, but the university does.
Right.
And so having the full-time researchers, these projects don't have to stop for finals week. They can continue during all of the academic breaks. We can continue to make progress on the research. So we use the innovative capability and the enthusiasm of the students and the academic faculty, but we also maintain continuity by having our own research faculty working here too. But what they really do is they sit down and they do all the analysis. The first 3 months have just been all work on the computer. We do a lot of drawings, understand the thermodynamics, understand the mechanical behavior, understand what kind of bearings you have to use, what kind of seals you have to use, what kind of materials you have to use. You go through all of those things, do all of the calculations that you used to do. But then comes the fun part, where we actually build prototypes. That's actually one of the things that also distinguishes this laboratory, is we actually build big things. So we can build these compressors in-house and test them. So after we get the theoretical part of it out of the way, we're then going to start building compressors and testing compressors so we can make sure that we get the cost down, the life down, and the cost down, the lifetime up, so that when we have something that's ready to commercialize, it's not just an idea, it's actually the third or fourth generation of a prototype.
All right, and we'll be back with more with Dr. Robert Hebner, the director of the Center for Electromechanics, right after this.
At BKD, we understand the constantly shifting nature of the energy industry. As a national CPA and advisory firm, we serve energy clients from the beginning to the end of the cycle. Our experienced energy advisors serve approximately 300 energy companies in exploration, midstream, downstream, oilfield services, and power production. Plus, we're the largest North American member of the Praxity Global Alliance, which means we can help you wherever you operate. Contact a BKD advisor or visit us online to learn more.
This is the Energy Makers Show, brought to you by NRG, moving clean energy forward. And now, back to the Energy Makers Show.
All right, continuing on with Dr. Robert Hebner, the director of the Center for Electromechanics at the University of Texas in Austin. Okay, now from what I understand, too, you're very early on in this process, right?
We are very early on. We're now just in the analysis part of the program. Yes.
Okay, so when you get funds, federal funds, like what you got from ARPA-E, does it have a time frame and does it have a target that you're...
It has a very definite set of targets, quarterly reporting requirements. We have 4 years to get this done and out and commercialized. And we fully expect to meet that.
Wow, sounds just like a regular commercial company.
It's like a real job.
Yeah, right. So, wow. So, what is the deadline, if I might ask?
Well, it's 4 years from now. We have to have it out. We expect to have it out and commercialized.
Okay. And did they get commercialized? Did they give you a target price too that you have to hit?
They gave us a target price. We hope to be able to get a lot lower than their target price. We would love to have a device for a few $100s that you can put in your home.
But that's impossible, right?
It's impossible today, but a lot of things were impossible 10 years ago that are possible today. So.
Right. So exactly how does it happen? Let's say that you complete your analysis, you make your recommendations, you prove that it worked. How does it get into the commercial world? Do you not play a role from that point on, and somebody else comes along and sells it to GE and those kind of people, or are you still involved?
It tends to be a declining involvement for the university.
Okay.
At this stage, we're very highly involved. As we start getting to the prototype, then potential manufacturers will start teaming with us, and they will be part of the effort. And as we start building prototypes, they will actually come here and work in our laboratories with us and be part of building the prototypes, and then they will take it back to their factories. And it's like watching your children go away. We have the empty nest. We'll have people who work on this for 4 years, and then they come to work, and none of the stuff is here anymore. It's very sad.
Right.
It's actually depressing. You got to go through that depression till the next project comes in. But that's part of what we need to do.
Right.
And the other thing that goes on is we have people who go with the project. Very often, the company will hire some of the developers that went so they could go to work on the project and stay with the project. Or they can give us a contract to help out as they go through. Because typically, on these commercialization tasks, we will get calls back for several years. Why did this happen? Why did that happen? So we can help them get through minor glitches that come up when you start using hundreds of thousands of these that we did not think of when we only had 2 or 3.
Okay, now speaking of your children leaving you, you shared with me a sonogram of your children at this very early stage, but we're showing it to our viewers right now. Describe what your early stage design accomplishes.
Right. Yeah, this is a single piston that moves back and forth. It's driven by a magnetic field or permanent magnets that drive the piston back and forth. And what it does is when it goes in one direction, it compresses. Part of the compression it does is actually pre-compressing natural gas for the other side. Part of it is pushing out to compress natural gas that goes into the vehicle. When the piston goes the other way, and again, it pushes out compressed natural gas for the vehicle and pre-compresses for the next cycle. So it's a very complex plumbing on the inside, but it's actually very simple technology. We know how to make permanent magnet motors. The world has been doing that for years, and that's what this is. It's a nice permanent magnet motor. We know how to make pistons that will do compression. We've got to do a lot of work on seals and make sure we don't heat the gas too high and many things like that. But we're trying to make a really simple device. You just push on it against the wall and compress it a bit and then let it go to the next stage.
What is the likelihood that design will stick with you all the way through?
In this case, about 70-30, but some of them have been 30-70.
Yeah.
This one is fairly mature. We've got a lot of hopes for it, but you're absolutely right. One of the things that you do when you're doing innovation is you suddenly hit yourself in the forehead and say, we got this wrong to begin with. If we'd have been smarter, we'd have done this instead. And that may happen still. It may happen after we build the first prototype. It may, who knows? But this one looks very good. We've done a lot of things like this before, and so we've actually gone through the stage a couple of times already. Right. So I think this one has a very good chance of looking a lot like this when it's through.
All right.
The real challenge is to make it smaller and lighter and cheaper. I really want something that you can pick up in one hand and set in your trunk, and maybe even have these, if it breaks, you can carry it back and hand it into your gas company. They'll just hand you a new one. Just like you pick up a new box if you're a cable company, if it dies. I'd like it to be that simple for the homeowner. The complexity here, of course, is the code requirements for natural gas.
Yeah.
I mean, you're going to have easy and foolproof ways of making connections.
Yeah. Well, in fact, your code requirement comment, as well as your comment a while ago about not having it heat up too much, almost everybody I know that I start talking about this possibility, they immediately, oh my God, who wants to put one of those in your garage? You're going to blow up your house.
Right.
Safety has to be a pretty big deal.
Safety is a major issue, but we don't plan on blowing up any houses. No, that would be a bad thing. And there's no need to. I mean, if you You have to realize all fuels are they're dangerous. You store a lot of energy in the fuel, and so what you have to do is engineer the risk out of the process. We're not at all unhappy putting cars, gas tanks full of gasoline in the garage because we've engineered out the problems out of that.
Right.
Now, at the beginning, they may require you to put it 3 feet from your house and run a hose through the garage. Right. But we expect to be able to have this as a reliable enough component that it's perfectly safe to leave inside the house. But that requires a lot of good engineering. You have to think of everything that can possibly go wrong. You have to do thousands of hours of testing.
I think it's real exciting. I love the idea of being able to do it at home and the abundance that we have right now with natural gas. The fact that it is burning generally cleaner than gasoline, correct?
Right. It tends to be about, on the average, about 20% cleaner than gasoline.
Well, Bob, I really appreciate you sharing your exciting story with us.
Well, thank you.
You bet. That's Dr. Robert Hebner, the director for the Center for Electromechanics at the University of Texas in Austin. And that wraps up this episode of the Energy Makers Show, heard on the radio and seen right here at TheEnergyMakers.com.